Hey everybody, this is Alex Merced from alexmercedcode.com, and this is a quick video to introduce you to the world of mobile application development. So the purpose of this video is not to teach you mobile application development, but maybe you're thinking about learning mobile application development. You're wondering, like, where do I get started? What language do I learn? What are my options? What's sort of the whole narrative? So hopefully at the end of this video you'll have a much better idea of sort of the world of options you have and what they mean. So always in the first place is native app development. So that means you're developing strictly for a particular platform. That means either the iOS platform, the Apple iPhone, or the Android platform for Android phones, like the Samsung Galaxy. Okay, now if you're developing for iPhones, the original language that was available for developing apps on iPhones was Objective-C. This is not really probably the way to go. This is a general purpose language. And what does that mean to be general purpose? It means you can use it for more than just one thing. So a general purpose language could be used for scripting, it could be used for developing backend applications, but Objective-C is a little bit older and it's a little bit more verbose, so it's a little bit more along the lines of like C# and Java. Let me see if I can find some example syntax. Yeah, so you can see like, it gets a little verbose. Okay, a lot of text. So what happened is that over time, Apple adopted Swift as sort of the heir successor, being like, okay, well, rather people use Swift to develop iPhone mobile applications because it's a bit of a simpler language, it's a bit easier to read, a bit easier to learn. Let's find an example of the Swift syntax. Okay, so see, like this looks a lot friendlier. So yeah, I can see like, I haven't looked at Swift in a long time, but I can tell here I'm declaring a function. These are the arguments. So it takes one argument that's a, that is a function that returns an integer, and it returns an integer, and it returns the results of the function. So this is essentially a function that's passed in. That's the argument. And then the function itself returns an integer. Like, it's a lot like reading JavaScript or Ruby or Python. It's with typing. It's not a particularly hard language to read or learn. Okay, so that's Swift. So if you want to develop mobile applications for iPhones, it makes sense to kind of learn the Swift programming language. But again, you're focusing on one platform. It doesn't mean, now again, Swift and Kotlin, which I'll mention later, are both general purpose languages. The languages existed longer than iPhone and Android. They've been around. It was just that Apple decided to embrace Swift as sort of the heir to Objective-C. So essentially, it has first-class support. First-class support meaning sort of like it's going to be the first to have access to all the latest phone features. So generally, that's the reason why you would use the particular sort of designated language. Because who knows, if you look inside the Swift library world, there may be libraries for helping you take Swift code and turn it into Android code, but it doesn't get the same first-class support that Kotlin gets. Likewise, there's probably Kotlin libraries that allow you to compile to an iPhone, but they don't get the first-class support that Swift does from Apple. Okay, so that is a thing. Okay, Swift. Now, in the world of Android, the language was Java. Okay, so actually I just saw the link to Java over here, so I might as well go over there. Java, probably one of the most popular languages of all time, along with like C++. And Java is still a very popular language to this day because a lot of code was written in it. Also, just because people love the thing called the Java virtual machine, which the idea when Java first came out was that you would run all your Java code in this virtual machine, so you didn't have to have Windows or Mac installed. You could write code and it would run either in both platforms because you just run it in the virtual machine. And this became very popular for sort of large enterprises and whatnot. But what happened is it's a verbose language. It requires a lot of typing. Like, let's find some sample syntax. Basically, this is hello world. This is hello world in Java. Okay? Because everything in Java, same thing similarly in C# and Objective-C, because they were kind of based along these lines. Everything's a class. So just to start your application, you have to give a class. And then anything your program does is essentially a method of this class. So essentially, your program is a main method of a of a class that's the app, and like that's a lot for just hello world, okay? And then like this is their version of like print or console log. That's system.out.println. That's a lot of typing. Okay, so point is, it's a verbose language. Okay, a lot of typing, still very popular. A lot of cool stuff is done in Java. Always a good language to learn. But again, if you're doing mobile application, if you're doing Android mobile application, you probably rather not have to type so much for basic applications. So there are other languages that run in the Java virtual machine. Okay, because people are like, okay, well, this Java, let me use Java to create other programming languages that can run in this machine. And the one that became sort of embraced by Google to develop Android applications is Kotlin. Let's find Kotlin. Probably is going to be over here somewhere. Kotlin. Guess it's not there. So let's just do this. Kotlin, programming language. But this sort of became the successor. Okay. And again, you can see this is going to be very similar to Swift. See, like, I can totally know what that means. I'm declaring there's a main function here. Let's see here, package my strings, fun. So here we're declaring a function. There you go, operator function point plus. So I think there you're just overriding. Yeah, you're overriding the plus operator. It's like, it's not super verbose. It's again much more simpler syntax, making it easier to develop your Android applications. Good times. So you have that option, okay? But at the end of the day, people rather kind of develop for both, and they don't want to have to learn a new language. So JavaScript is probably like the most popular alternative to learning Kotlin or Swift, because JavaScript, you have to learn JavaScript. If you're going to do any kind of web development or front-end UI development, you're going to need to know JavaScript. So there are two ways to develop apps in JavaScript. There's React Native. React Native allows you to use the React framework. Okay, and see, your code looks just like React. The only difference is instead of using divs, you're going to use like this view component. Instead of using like p tags, you use like this text component. And then there's like an image one, because what happens is that when you're developing on iPhone or Android, let me go to core components. This is a really good visual. What happens is that essentially Android and iOS have their own terminology for like view elements, like the actual things you see in the phone, because technically you're running in the phone, you're not running in a browser per se. So essentially what happens is that you are, and then again, really what you're developing is the UI, because like a lot of the guts, like the back end is still just a back end server somewhere that you're pulling data from through fetch calls. At the end of the day, like that part doesn't really change. So it's just developing the UI. So in Android, their like version of a div is called the view group. In iPhone, it's called the UI view. Instead of a image tag, there's image view on Android, UI image view on iOS. And if you're talking about like a p tag for text, there's text view on Android. So then what happens is that the React Native and actually all of these other frameworks I'm going to talk about, really what they do is they translate these things into the appropriate elements for the appropriate platform. So the React component's called view, but when it's compiled to Android code, it turns into view group or turns into UI view, and you get the idea. So when you develop in React Native, it feels just like you're developing in React for the most part. There's still a little bit of a learning curve because there's like different events like on press and stuff you gotta learn, but it's not a huge learning curve. Okie dokie. Then there is NativeScript. NativeScript allows you to use any JavaScript framework. It's just basically JavaScript for developing mobile applications. They do have templates, so you can use Angular or Vue right out of the box, but you could theoretically use any kind of JavaScript framework you want. Okay, so for example, Svelte, which is another front-end framework in JavaScript, develops Svelte Native, which is really just a template for NativeScript. So what they did is they created their own NativeScript build, and then you can go over here and then develop a mobile application using Svelte if you want. Okay, so NativeScript allows you to kind of use literally anything you want in order to do your mobile application. And it does a lot of the same stuff. So let's go to the docs. let's go to the components, and here essentially you have different components. So you have like a button component, okay, but then it compiles to whatever native UI component, label, text field, text view, search bar, switch, slider, progress, activity indicator, image. You guys get the idea, okay? But you have all of these kind of components available to you to build your mobile application. So that's another way you can build a mobile application if you want to, and you could literally build your own framework or use any other non-React framework if you want. So that's what's kind of cool about native script. So those are probably the next popular choice after using Kotlin or Swift. Then probably the next most popular choice is going to be Dart. Dart is another general purpose language. So again, you can do more than just mobile applications with Dart. Let's take a look at some example tag code. Language samples. Okay, so for example, there's hello world. See, that's a lot less than that Java hello world. And see, that's pretty easy to read. Okay, like this is all pretty understandable to read. Variable, this an array of strings. Like it's if you know JavaScript, Dart's gonna be pretty easy to read. It's very similar. Okay. Some slight differences, but nothing too crazy. You do have typing. But at the end of the day, even in JavaScript, everyone's using TypeScript these days because typing just makes your code safer and less buggy. Okay, even though it's a little bit more work. Okay, so you have all sorts of cool syntax here. But the cool thing about Dart is that with the Flutter compiler, you can compile it to mobile applications. But the idea here is you can use it anywhere. So here, like, you can use Dart just as like to create desktop applications, whatever you want, mobile applications, whatever. But you can also use Dart in the web. You can compile it to JavaScript. So it'll get compiled to JavaScript, and in that case, you'll be able to run it in the browser. So you can literally do anything with Dart. Okay, you just compile the code and it runs in the targeted thing. But the thing is that it's really popular for is mobile applications. That's sort of the big thing that everyone's using it for, particularly with the Flutter compiler. Okay, the Flutter framework allows you to make mobile apps. That's what provides all those components that translate into like Google's UI, or I mean Apple's UI view or Android's view thing. Okay, so that's what that does. So that's Dart. Now, other languages have their own mobile platforms. So like if you're in the .NET world, there's Xamarin. So if you know the languages C#, F#, or VB.NET, that's kind of like what you use in the Microsoft's .NET universe. It's kind of like literally its own little programming universe, separate from everything else. Xamarin would be the framework that allows you to create mobile apps. Like Microsoft has its own little universe for everything. So they have Xamarin for building mobile applications. They have what's it called? Starts with a B. Let's see here. C#, .NET build front-end apps. Blazor. It's called Blazor. Blazor is their framework, so you can actually do front-end work with C# and F#, which is pretty cool. But that's a whole world in itself. It's like a Microsoft sort of like little walled garden. So generally, if you're like you learn .NET, you're kind of like all in because it's just like a lot of work to learn all that. There's a lot going on, but you can do that. Xamarin. Let's see here. Then there is Kivy for Python. That's Python's framework for developing mobile applications. So if you want to develop mobile applications in Python, you have Kivy as a framework for doing so. You have Ruby Motion, which is a Ruby platform for creating mobile applications in Ruby. Okay, so you can create mobile applications in Ruby using Ruby Motion. I think there was Go Mobile if you wanted to use there we go. Regional Handler Authority. Go Mobile. Download the new Go Mobile. No, that's something else. Go Lang mobile app development. Here we go. That's right. Oh, Go apps for Android and iOS. So see, there's like different tools for that. That's not really what Go's known for, making mobile apps, but people have made libraries so you can do it if you really want. If you really like Go, that's or and I like Go a lot. That's a fun option. But if you're looking to work in mobile app development, think of the order that I covered these as sort of the the priority of which you're most likely to get a job. And then you can probably find all sorts of one-offs. Like, I mean, I think PHP mobile application. There's this Kick framework, so you can develop mobile applications in PHP, which is pretty cool because PHP is not a general purpose language. PHP really was kind of strictly made for the purposes of building web backends. Now there is like PHP CLIs that allow you to do a little bit of PHP scripting, and you can do more with PHP nowadays. And PHP is a really cool language worth knowing. But it's kind of interesting to see that someone actually was able to make it work for mobile apps, so that's neat. Aside from that, I think that's a pretty good coverage of sort of what your options are if you want to develop a mobile app. So bottom line, just to kind of recap, sort of tier one is learning the native language, so learning either Kotlin or Swift, depending which platform you want to develop for. Now, if you want to do cross-platform development, then the second tier sort of options, the biggest cross-platform options are going to be Dart Flutter. Okay, you can find jobs in working in Dart with the Flutter compiler, or you can find jobs in React Native or NativeScript. So those are sort of the, I would say, second tier. So those are cross-platform options that allow you to develop for both in one. Then you have sort of a lot of other cross-platform options. I know I'll add Xamarin to that option. Xamarin's also would be in the similar. So you can put Dart, Flutter, Xamarin, React Native, and NativeScript sort of in the same tier. Sort of like, can I find work? Yes, you can. We're talking about like Go, the mobile app framework in Go, or Ruby, or Python. Probably less so. They're probably better if you're just really good at those languages. So you want to use a language that you're really comfortable with to build a mobile app for your own self, or you're doing a startup and that's the way you want to go as a startup. That's fine, and then you create jobs in those frameworks. That's kind of how it happens. You create a startup with the tools that you like, and that creates jobs in those tools, and then that tool ends up surviving. But that is sort of the world of mobile app development. And again, you always have the option of what's called a progressive web app development. What if you don't want to deal with the App Store? You can build a progressive web app. A progressive web app is essentially a web application, so you're still using HTML, CSS, and JavaScript, so you don't even have to learn like a separate framework like React Native. You can just use React. The difference is how you build it. So you build it, it's very mobile responsive, so the UI feels like when you have your browser in sort of mobile view, it's going to feel a lot like a mobile application, but at the same time, you also use things like service workers is what I'm thinking of. And service workers are like little allows you to create other processes that run simultaneously along with your web application. So that way you could have like a little mini server that's kind of running, or have other kind of processes that allow for more like offline running of your web application and other cool stuff. So, and it takes a lot of advantage of sort of like in-browser databases like IndexedDB and local storage. But the idea is at the end, by taking advantage of all these things, you make an application that feels a lot like you're using a mobile app native to the phone, by taking advantage of browser APIs to make it. And then you don't have to worry about like app stores. You don't have to worry about cross-platform compatibility. And in most phones nowadays, you can actually take like a website you like and basically make it an app icon. So theoretically, someone can go to your progressive web application, hit a little button in the browser on Windows or Android, and it'll get its own little separate app icon and basically make it feel like a full-on app without actually being an app in the App Store, without having to pay the fees or wait for the approvals. So that's a trend that probably may pick up in the future, and that might be, in the future, if that really picks up, that might really kind of change things, but that's something to be aware of. Cool. So I'll leave it at that. My name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.